An impure sample of zinc metal weighing 1.70 grams reacted completely with 25.0 centimeter cube of 1.50 mole per dm cube hydrochloric acid. So we're asked to write a balanced chemical equation for the reaction. Question 1. Question 2, we're asked to determine the mass, first of all, the mass of pure zinc, and then the percentage purity of the sample. And we're given the relative atomic mass of zinc. So we're given these values. We are asked to write the balanced chemical equation for the reaction. All right, so that should be, we're talking about zinc metal and hydrochloric acid. So it's given in volume. So basically, it's going to be an aqueous solution. So our zinc should be solid, all right, because the metal, and then HCl. Okay, see that. Let's give the states. So it should be in solution, and then you have zinc chloride, because there we have the reaction zinc chloride. Okay, we should have 2 atoms there, and it should be soluble, and then plus hydrogen gas. All right, likely. So if you look at it, you see that we have on the right hand side we have 2 atoms of chlorine, but we only have 1 atom of chlorine here, and we have 2 atoms of hydrogen. We only have 1 atom of hydrogen there. So if we are to do this, that should balance for hydrogen atoms, both left and right, the reactant and product side, and also balance for chlorine, both reactant and product side. So that answers the balanced chemical equation for the reaction. Next, we're asked to determine the mass of pure zinc. So it's the pure zinc that will react. So let's get the mass of pure zinc that reacts. Okay, of course, the impure part of the sample will not react with the hydrochloric acid. So let's get the mass of pure zinc. We're going to use the moles of HCl which was consumed and compare that with the zinc using our mole ratio from the balanced chemical equation. We can get that from the formula N equals to CV. That's number of moles is equals to concentration in mole per dm cube times volume in dm cube. For our case, we need to find the moles of HCl. So concentration in mole per dm cube, we're giving that as 1.5 times the volume in dm cube. Now we're given the volume in centimeter cube, so convert to centimeter cube to dm cube, just divide by 1000. All right, so this will give us the number of moles that actually reacted, okay, for HCl, and then we use that to measure zinc. We're trying to determine the mass of pure zinc in this reaction. So the mass of pure zinc in this reaction. All right, so we're going to use the moles of HCl consumed. Using our formula, number of moles is equals to concentration in mole per dm cube times volume in dm cube. We need to find the moles. We can find the moles of zinc that reacted using our mole ratio. Moles of zinc that reacted. So it's going to be half. So to take half of this, half of whatever is reacting here for zinc. Zinc is half of this. 1 is half of 2. All right, so I'm going to, the moles of zinc that will be half of all of this. Okay, because it's ratio 1 to 2. 1 mole reacts with 2 moles. Hence, half of this will be the moles of zinc that reacted. So I'm going to half all of this. Half of 1.5 times 25 all over 1000. Okay, so this is the moles of zinc that reacted. We could leave it like this, okay, because we are here to get the mass. So to convert from moles of zinc to mass, all right, we could just multiply all of this by the mass of mass of zinc, or rather the relative atomic mass of zinc. The relative atomic mass of zinc. All right, so say mass of pure zinc, because that's what the question is asking for, not moles. So we need to convert our moles to mass. Mass of pure zinc that reacted. All right, we just multiplied number of moles by the relative atomic mass. So it's going to be all of this 1 over 2 times 1.5 times 25 over 1000 times 65.0. That's it, 65.0. So that's what gives us the mass of pure zinc. All right, so we've been able to write the balanced chemical equation for the reaction. That's it there. All right, then we're able to determine the mass of pure zinc. So the mass of pure zinc is this. Then if you point that into your calculator, you get 1.22 grams. That's to 2 decimal places. Lastly, we need to find the percentage purity of the sample. It's very simple to find the percentage purity of the sample. In this case, we're talking about the purity of the sample zinc, because we're told that's an impure sample. So just get the mass of pure zinc. okay, that reacted all over the total mass of the whole impure sample, then express it as a percentage, because the question says determine the percentage purity of the sample. All right, so we get mass of pure zinc, which we've gotten from this previous step, and then total mass of the impure sample of zinc, then express it as a percentage. That's just multiplied by 100 over 1. All right, so this gives us the percentage purity. So if you point that, let's get that. We're going to have now the mass of pure zinc we've calculated from this step as 1.22 grams. All right, and we're given the mass of the impure sample of zinc from the question. An impure sample of zinc metal weighing 1.70 grams. So put that as impure weight, then expressed as a percentage. All right, so if you point that into your calculator, you're going to get roughly 71.76%, or you could say 71.8 if you're taking it to one decimal place. So the answer is this, okay, which is approximated to this. All right, so whether this or this. So it's just simply percentage purity is always mass of the pure sample all over total mass of the impure sample times 100 over 1, because we are expressing it as a percentage. All right, so that's the final answer. So I hope that was clear.